Assalamu alaikum. Today we will discuss about the first lecture of quantum mechanics and what is the quantum mechanics. In quantum mechanics we learn small level of things are simple. Atom is the small, but inside the atom we study particles, for example neutron and proton. In phenomena partially and subparticles study in quantum mechanics. Quantum mechanics is divided into two different portions. First one is quantum mechanics 1 and second is quantum mechanics 2. Quantum mechanics 1 we study in first semester and quantum mechanics 2 in study sixth semester. No, quantum mechanics is used when classical mechanics is failed to describe some phenomena. Firstly, we study the state of the system, what is the variable and what is the dynamic variable, what is the difference between linear vector space and Hilbert space, and what we study in this course: operators, linear vector space, Hilbert space, Dirac notation, orbital angular momentum, cylinder equation, one dimension potentials, the hydrogen atom, and free particle and particle in a box. We study our today lecture. Here the outline of the lecture. Firstly, we discuss about mechanics. We study mechanics in the first year, second year classes. Basically, mechanics are movement or motion of a body or object and also particles and some one term in classical mechanics. And what is the mechanics? Is the study of movement of body at large scale or bigger object than relative mechanics. Relative mechanics is the study of other relate of the object. For example, a car move and then other car is also moving. To relate speed of one car of other car, relative mechanics. Also study the speed of light and things of object which relate with the speed of light and close to the speed of light. And last is the quantum mechanics. Basically this course is quantum mechanics. In the whole courses we study mechanics and term and what is the meaning of mechanics we detail discuss in the lecture. And next is the historical view and particle aspect of radiation and wave aspect of radiations. Next, mechanics. Mechanics physics concerned with the motion of body under the action of force, including the special case in which a body remain at rest. Is background of quantum mechanics, which when developed quantum mechanics after classical mechanics, and classical mechanics failed when we explain the different phenomena and object. Scientists is induced the quantum mechanics. Then particle aspect of radiation, it means the nature of the matter behave like a particle and behave like a motion. Then wave aspect of radiation means matter behave like a wave and behave like a particles. And next, classical mechanics. Classical mechanics, the motion of bigger things and object, the study of classical mechanics. It deals with the motion of bodies under the influence of forces and when the equilibrium of body when all forces are balanced. For example, movement of objects small and large. And quantum mechanics. Quantum mechanics is the study of small object. Defined as branch of physics which that deal with atomic and subatomic system, or a mathematical description of much of the dual particle like and wave like behavior and interaction of energy and matter To explain the structure of atom, atomic nuclei and molecules, the behavior of subatomic particles. Some following properties know about what is the quantums and quanta. Define system quanta. For example, we count easily, for example counting 1 2 3 and so on. We cannot easily. And Max Planck, de Broglie, Einstein, Ginder and other scientists discuss about the and explanation is quantum mechanics. And historical view. After the 19th century, physics consisted of classical mechanics and thermodynamics, and 20th century classical physics was seriously challenged by two major fields, relativistic domain and microscopic domain. Classical mechanics failed when the nucleus explained the structure, subatomic particles, and etc. And classical physics failed to describe microscopic phenomena such as black body radiation, photoelectric effect, and atomic stability and atomic spectroscopy. First, what is the term of black body radiation? Basically is the phenomena of thermal radiation and thermoelectrical radiation with a surrounding body in thermodynamic equilibrium with its environment. For example, a black body emitted electromagnetic radiation within the body and the outside of the body. And second is photoelectric effect. Photoelectric effect is the phenomena in which electrically charged particles are released from with the material or surface when it absorbs electromagnetic radiation. Means some photon light is fall on the surface of the metal, then emit electron means emit electrically charged particle. This phenomena is called photoelectric effect. Then is the atomic stability. Atomic stability means an atom is stable if the force among the particles that make up the nucleus are wedged. For example, inside the atom here is the nucleus, and if the nucleus make the neutron, inside the nucleus is particle neutron and proton, and if the force among the particles that the make the nucleus are balanced. Balanced mean force between the proton and neutron are balanced and nucleus is stable. This phenomena is called the atomic stability. And last is atomic spectroscopy. Basically explain the atomic spectra. Atomic speed is the atomic spectroscopy is the study of electromagnetic radiation absorbed or emitted by atom. An atom release or absorb some electromagnetic radiation. This phenomena is called the atomic spectroscopy. Then wave aspect of radiation. De Broglie hypothesis, matter wave means any particle of matter that has linear movement means velocity and mass is also behave like a wave. The wavelength of a matter is associated with the particle is inversely proportional to the magnitude of the particle. This is basically de Broglie hypothesis. Like matter behave as a wave. And then experimental confirmation of de Broglie hypothesis is basically Dervas German experiment which explain the wave nature of matter. Dervas German is that experiment is that matter wave like behave, and with the help of scientist Compton effect and also Nobel Prize of Physics 1927 establish the wave particle dually nature. And then is the Thomson effect. Thomson experiment. Thomson is scientist J.J. Thomson explained plum pudding model. For J.J. Thomson, which negatively charged particles is bending in positive charge particle. This experiment is plum pudding experiment. And then matter wave of macroscopic object. Next is particle aspect of radiation, black body radiation, photo electrical effect study in previous slides. And then explain is the Compton effect. What is the Compton effect? In Compton effect and pair production, Compton effect is the phenomena that occur when a proton shattered off an electron, transferring a position of its energy to the electron. The Compton effect was discovered in 1923 by American physicist Compton, won the Nobel Prize 1927. The effect of its result of quantum mechanics and especially realistic and its derivatives from classical theory of how electromagnetic wave interact with atom. And last is the pair production. Pair production is the process where a high energy proton or gamma ray is converted into a subatomic and its subatomic particles and its antiparticles. For example, a proton creates an electron and a positron or a mu and anti-mu. And if there is any confusion in the lecture, we ask in the comment box.